Hello, hello. How is everyone? I hope you guys are having a great morning, afternoon, evening, wherever you're joining us today from. And I hope you guys are all excited for the launch of our Generative AI Educate series with Boba Network. So we've got a really exciting workshop today. By Kevin and Alan from Enya Labs. But before we get into that, we've just got a couple of housekeeping bits to get through really quickly. Hi, my name is Adriana, and I will be hosting these Educate workshops. My Twitter and Discord username and handles are on the screen there. Please don't hesitate to reach out, ask me any questions. I will be more than happy to help with anything you guys might need. For those of you who don't know, we are Encode Club. We are a developer community that helps developers learn, build, and forge careers in emerging tech. We run a number of different educational programs. So we run educates like this one. We also put on hackathons, which then kind of help in with accelerators. And we also do longer form educational content like boot camps, and also help with recruitment into Web3 roles. So today we are launching the Generative AI Educate series with Boba Network, like I said, and we've got a number of really exciting workshops coming up. So today we have Alan and Kevin from Enya Labs, and they'll be kind of giving their workshops on integrating AI with Boba Network's HybridCompute. And then we've got another exciting one this week with Google Gemini. And then next week we've got blockchain at Berkeley, another Enya Labs, and then the week after next we've got we've got Kamish from Refuel coming, and another workshop to be announced shortly. All of the workshops will ideally be at exactly the same time, so 4 p.m. GMT time, 5 p.m. CET. So make sure to tune in at this time to be able to watch the recording, to watch the workshops live. Of course, everything will be recorded and uploaded to our YouTube within 24 hours as well. So if you miss the live session, you'll be able to see it recorded on YouTube. Also, before we jump into today's workshop, please feel free to join our Discord, scan the QR code there to keep kind of up to date with all of the information about this Educate series, meet other participants from it, and kind of join the community. And also on the right there, if you scan that, it will take you to our programs page, so you can find out about more exciting programs upcoming. However, today we are launching the Generative AI Educate series, and I'm just going to invite Alan up from Enya Labs as he will be giving his presentation. And I will also stop sharing my screen. So Alan should be getting ready. Hope you guys are excited. Yes, we've got a lot of fun things coming up. So yeah, exciting times. Alan, amazing. Hello.
Hello, Adriana. Hello, everyone. How are you doing?
Good. Whenever you're ready to share your screen, present, the stage is all yours.
Can everyone see my screen okay?
Yes, good.
Let's launch in. So I wanted to kick off the series with a quick talk around how AI agents are transforming Web3. They are really opening up new possibilities around user experiences and what we as developers could build and offer to our users. So I am the CEO of Enya Labs. We are the co-contributors to Boba Network. Boba Network is a blockchain platform for building hybrid applications. And hybrid applications are blockchain applications that integrate with off-chain APIs, such as AI agents that offer a richer and more powerful user experience. Now, the next wave of Web3 innovation is really here because of AI. We've all seen how AI has changed how software operates. It's changed how we do our work, from coding to marketing to lead scoring to writing, you name it. I am sure everyone is using by now using some sort of generative AI regularly to help us be more productive and more creative. Now, what does that mean for the Web3 space? It means we are now able to bring the best of both worlds together. What Web3 technologies offer are benefits such as self-sovereignty. You can own your assets, you can own your digital assets and bring them with you. Censorship resistance. Blockchain platforms are censorship resistant. Users can interact with any dApps they want without asking for permission. Developers can deploy on any blockchains they want without asking for permission. And all the transactions that happen on a blockchain are transparent. And smart contracts are also transparent. You can inspect the source code on chain. And these benefits can now be combined with the benefits of AI agents, which, first of all, bring together the collective intelligence of all of humanity. Everything that we have learned across many different specialized fields can now be accessed through AI agents. And these AI agents can also simplify our lives by being actors of abstract and complex tasks, and instead of giving very detailed step-by-step command, we can now ask AI agents to perform at a more abstract level, and they will figure out in a more detailed level what to do. And this is most prevalent, most obvious in programming, for example, as more and more developers discover that they can just ask an AI agent to create a web app with them for them by specifying a number of high-level requirements, and very quickly an AI agent could build a prototype that the human developer can then go on and tweak. AI agents can also act as autonomous assistants that have a memory and can carry out tasks over a period of time to optimize for certain objectives. And so how do we actually bring these two worlds together then to offer these benefits together in one application to our users? Well, let's take a look at how traditionally decentralized applications, or dApps, interact with the world. In the past, it has been primarily human users who interact with dApps. They want to execute a trade or swap one kind of token to another, and they would ask a dApp to do it for them. And nowadays, oftentimes there are AI agents interacting with dApps as well. These AI agents might have been given a crypto wallet, that is holding a certain number of tokens by its creator to optimize for certain objectives. Now, in both scenarios, the dApps are somewhat passive in terms of just receiving commands from either a human user or an AI agent, and then carrying out these commands. But the future, we believe, is going to evolve to one where a dApp would interact with multiple AI agents, calling them back instead of simply receiving calls from them. And Boba as a platform enables this type of two-way interaction between dApps and AI agents, and the future is exciting. And that makes Boba Network really the ideal home for Gen AI dApps, and you can create your dApps that tap into the power of your favorite Gen AI API services. And at this point, there are over 100 developers and partners on Boba Network. Now, how your dApps can actually talk back to AI agents, let's break it down. And Kevin will go into a lot more details after my overview talk. So first of all, on Boba Network, we have created a capability called HybridCompute, and it's really easy for developers to take advantage of this powerful capability. you only need to make a one-line call to extend your smart contracts, and this call will make a call to any Gen AI API such as ChatGPT or Gemini, and you can get your and these requests are triggered during the gas estimation process of a smart contract transaction, and the responses are cached in memory for efficient processing. And unlike Oracle solutions, HybridCompute works differently. It does not depend on any external processes to push data on-chain. It uses a poll model where off-chain data or the response from a Gen AI API is only requested on demand. Now, to make these concepts concrete, the engineering team at Enya has built a couple of examples and put them on GitHub for everyone to explore, and hopefully will serve as inspiration for all of you as well on what you can build in your context and for your industry and for your users. And later on in the Educate series, we're going to have dedicated workshops focused on how these examples work and how all the pieces fit in together. But just to give you an overview, the first example I want to talk about is something that's called CodeCaster. What is CodeCaster? Well, CodeCaster translates text commands into smart contract transactions, and the idea, and a team put this together in the course of a couple of days. The concept is to streamline the HybridCompute interface by making blockchain transactions accessible via natural language. And in this iteration, we have chosen English as the natural language interface. And for example, a user can simply type send 0.001 ETH to an address such as alice.eth, and CodeCaster will translate this into executable transaction data. Well, how does it work? Well, first of all, the user would create a natural language prompt, right? And then HybridCompute would pass the request to an off-chain handler. And in this example, we use ChatGPT to parse and structure the prompt into parameters, generating the smart contract call data, and then the data that comes back would be used as part of the call data into the transaction. And we've built CodeCaster to support commands such as transferring tokens, approving certain transactions. You can even create conditional transactions. For example, you can do things like, oh, if today's weather is sunny, or today's temperature is above a certain number, then proceed with the transaction. You can also do currency conversion. So instead of saying, I want to send 0.001 ETH, you can say, I want to send $100 worth of Boba tokens to alice.eth, to a wallet address, and CodeCaster would translate that command into call data for you as well. So feel free to play around. The GitHub repo is here. Again, like I said, we're going to have a dedicated workshop for CodeCaster later on in the Educate series to unpack its inner workings. Another example that we built is called PreziBot, which is an interactive political simulations. It's kind of a fun game. So this is what it does. It enables users to role play as decision makers in realistic political situations or economic challenges. It uses HybridCompute to ask AI to generate questions based on current events, and then users would have a chance to submit policy proposals. The dApp will select a daily winner picked by the AI agent. For example, a situation might be, oh, as president, what is your policy response to persistently high inflation, which has been a challenge that many political leaders have had to grapple with over the last several years. So how PreziBot works is it uses HybridCompute to generate a scenario, in this case using ChatGPT, and then users will submit policy proposals that are stored on chain. And after the submission period closes, such as 24 hours, then ChatGPT would evaluate the proposals and selects the best one based on the quality. Again, the code is here on the GitHub repo. is a fun game that our team put together, and you can extend this in a lot of different ways to make it engaging and fun for your users. What else can you do? Well, you can imagine a meme coin or NFT with AI personalities, you can pick a celebrity or fictional character and infuse that personality into a meme coin that could perhaps tweet on X. You can also imagine creating an on-chain lending protocol that uses its own friendly AI agent that you've trained for fraud detection. Right? So before the on-chain lending protocol approves a loan, it's actually going to consult with this AI agent to say, hey, this is the loan request. These are the parameters coming in from a certain address. Like, what is the likelihood that this is a fraud versus not? And you can also use your existing AI models. For example, if you're a fintech company, you've been training your own risk model for either loan approval or some other purposes, and you can now use this risk model, turn it into AI agent that interacts with an on-chain dApp that you create. So there are really a lot of possibilities. You're only limited by your imagination. We have a Boba Builders group in Telegram. Some of the folks who are interested also in building hybrid applications have joined this group, and you can ask our developers any questions or if you have any issues that you run into in using HybridCompute to integrate with Gen AI, feel free to just drop them in this Telegram group. And at this point, I'm going to hand it over to Kevin to unpack the technical details of HybridCompute and how you can use it to leverage Gen AI services.
Amazing. Thank you so much, Alan. That was a great overview of Boba Network and Enya Labs. So Kevin, you should be getting an invite shortly to come up and kind of give a bit more of an in-depth technical overview. Amazing. Hello.
Hi, everyone. Yeah. Hi. Well, thanks for having me on. And yeah, I will also start sharing my screen. One sec. Okay. Cool stuff. Does it work?
It's just loading. Yeah, perfect. Great. Cool. So whenever you're ready, go for it.
Sure thing. Well, hi everyone. Like in this session, we now mostly focus on the use cases, like some other cool things that you could actually build with HybridCompute, just to spark your imagination a little bit, to trigger some discussion as well. And then, of course, we also go into the specifics, like how do you actually use this? How difficult is it to build with HybridCompute? And what kind of skills would you need to implement that? That's what we are focusing on now. So let's start with the super high level basics. Again, just to make that really clear, Alan did a great job at highlighting that. Basically, you can use HybridCompute for two major use cases, which means on one hand, you can just offload heavy or maybe even confidential computation off chain. Right? Whatever that is up to you, of course. But you basically could do anything on there, right? Because EVM, as you might know, is quite limited in the computation that you can conduct on chain. But here you got a lot more possibilities. When it comes to the other side of things, for example, integrating third-party APIs like Twitter, X, TikTok, which I think is on again in the US, all these kind of things, or more specifically, even Gen AI or quantum computers and all sorts of other crazy stuff that you can imagine. That's possible with HybridCompute, right? So whenever you want to offload heavy computation, or when you want to request or pull data from some sort of third-party APIs, which could be AI itself, then that's possible, right? So let's dive into a few more detailed use cases or ideas for things that we think could be really interesting if we build that with hybrid compute. So one of them being, for example, AI model inference off-chain, which means you basically, in simple terms, you have your AI model somewhere, right? ChatGPT, your own open source model that you fine-tuned, whatever you have, right? Even if it's with corporate data and all these kind of things. Then you basically have your smart contracts, your D-apps, and your application talks with that AI model, right? And you pull the response from off-chain to on-chain, right? And do something with that based on that reply, which, for example, PreziBot is a great example for that, or CodeCaster as well. So anything that you push off-chain, pull on-chain, has the source from an AI model, basically would fall into that category. That, of course, has aside from like accessing AI at all, which on-chain is, as you might know, really difficult or not possible at all with most platforms out there. You basically would gain native access to this kind of data or information, right? And you could directly interact with it. So that's kind of the power, and I think the difference that I want to highlight here a little bit. Like with oracles, you always need to wait for the data, right? You make the request and you wait a couple of transactions until you receive the data in your callback. But with hybrid compute, you get the data in the same transaction. It's like one atomic transaction. So basically, you have your smart contract, someone triggers the transaction basically, and you get the response in the same transaction. And you directly in the next line of code can work with it, just like in Web2 as well. And that's the beauty of it, right? For example, another use case, which is very, I would say, a cool thing that you could do with it is like token gating, right? For example, if users hold NFTs, tokens, and you basically could gatekeep your premium AI model or certain capabilities or these kind of things, or just other services that you offer, right? Doesn't need to be an AI service or AI model that you provide, but it could also just simply be a SaaS, like software as a service or these kind of things. There's a lot of things you could include or develop natively with that without going for workarounds and these kind of things, or really complex software architectures, or focusing on stuff that you actually don't want to focus on. That, of course, gives you the power of blockchain ownership, verification with off-chain AI capability, for example, again, or like general, just providing some kind of a monetization strategy for your project, aside from raising funds through NFTs and tokens, of course. For example, what you also could do is federated learning, which means with hybrid compute, you could gather information from different, let's say, participants and aggregating them off-chain. Right? For example, your D-app users could provide information in some way, whatever, and contribute to your AI model, right, in a traceable and transparent manner. And this way, you could build federated like AI models that have been trained through federated learning, basically, which is also really interesting. There are a lot of papers out there as well, so that could be a really interesting scientific approach to hybrid compute as well, especially as it becomes less biased, maybe even, like, without being a data scientist myself, because you have different sources of information, right? Of course, the standard use case when it comes to blockchain and content or social media is ownership of generated content, right? But a big pain that I think a lot of people already experienced is that when you use Gen AI for generating content, you oftentimes don't know is that who did that, where is it originating from, and so on. And with AI, of course, you could like generate the content and put the stamp on it through hybrid compute. Also, as Alan already outlined, you could build decentralized AI agents, which is a really hot narrative, of course, for 2025. So Boba Network might be your choice here. And you basically could build AI agents or smart contracts that, let's say, interact with AI agents and all these kind of things, right? So basically, your imagination, your creativity is your boundary. Right, so it's really about that seamless interaction between off-chain AI and on-chain smart contracts, for example. A little bit more narrow, of course. I know a lot of people have been burned with GameFi in the last few years, but of course, Web3 gaming is still a thing and is becoming more and more interesting as the space evolves as well. So, of course, NPCs, non-player characters, could be also a really interesting use case for hybrid compute, since gaming requires you to have superior user experience. Like if you play your Web3 game, you don't want to wait for off-chain data, right? So oracles might not be the best choice here, but hybrid compute with directly returning you the data right away, instantly, might be a cool choice here. And since you can access AI with that, that could enable your NPCs to do some pretty cool stuff. Of course, we could also do some other things when it comes to DeFi, for example. Like one use case that a lot of people have been building upon is that social reputation. Like when you go for a loan on a bank, you usually don't have over collateralization, right? When you lend money, like when you lend $1 million, you don't have $1 million somewhere else in another asset like you need right now in crypto. Like you always need to provide more capital, or oftentimes with a lot of platform, but instead you provide your name and other people to it. Like with that, okay, that person earns that much amount of money every month for these kind of things. With hybrid compute, you actually could do that, or you could implement that off-chain source of truth, right? Be it like a less, let's say, a popular approach could be KYC, of course, or you could also just fetch off-chain like credit data from some sort of API or whatever, and incorporate that into your application, for example. So these kind of things would be possible as well. Of course, the standard use case as well, supply chain transparency. Supply chain use cases in blockchain oftentimes had the issues with combining off-chain data sources with on-chain source of truth. Right? That was oftentimes a huge challenge a lot of companies face when they try to implement supply chain use cases. And here with hybrid compute, you could merge these things easier together. Gaming asset generation, very similar to our previous one. Generate gaming assets through AI, for example, could be your 3D assets and all these kind of things. And also back to KYC, you of course could add KYC to certain smart contract functions, for example, right? For example, when you want to do something with your, let's say, GameFi character, or even with your token, you could implement, like, for example, just putting something on top of my head, like if you want to swap your Trump token to X, then you need to KYC yourself, for example. I know we all don't want that, right? It's blockchain, but these things would be possible just to spark your imagination. Or IoT as well, getting off-chain data on-chain, real-time fashion, one transaction, possible as well. So how does it work, right? In general, hybrid compute is based on account abstraction, which means you need to have a smart wallet, right? And that smart wallet, as in all account abstraction alternatives out there, like we follow the standard, communicates with the bundler, right? You basically send a user operation there. And what then usually happens is one of two things in very simplified terms. Your transaction or user operation that would trigger an API request either already has a cached response, right? Then we basically just return that if it hasn't expired so far. Or if you have something in your storage, you basically need to trigger the API, like to your ChatGPT model, for example, which could be here, right? You have your own backend, you do something with your data, whatever, return the result to smart contracts in a format that it understands it. And here you basically do have these third-party providers, which could be Twitter, ChatGPT, Claude, whatever. And if the request was successful, we save it in the response cache. So of course, there are a lot more things happening under the hood, right? I don't want to confuse you here, but if you're curious, like I think I'm allowed to share the slides. Also happy to go over these things after the session if you got some questions. But basically you need to do two things. You have the gas estimation flow, like when you send a user operation, you actually trigger the API request there. Like that's what is happening here. And then like when you actually send the user operation, we basically request the cached result from the previous gas estimation, right? So the first call would be the estimate user operation that you see here. And the second call is the actual execution if the call has been estimated already. Also, like that's the estimate user op, sorry, and this is the submission all the way around. So that's the submission then, where we access the cached version. So on the technical point of view, these all might sound very complicated, but we did our best to make it super easy. So for that reason, we got 3 SDKs for you. On one hand, we have the Frontend SDK to invoke your smart wallet, to send the user operation, to estimate the gas and all these kind of things. We also got 2 SDKs for people that prefer TypeScript or Python for the backend. So that's basically the server or the service that is being accessed by your smart contract when you trigger an API call, right? And that backend does whatever you want to do, right? It makes a request to ChatGPT, it accesses Twitter, it does some crazy stuff with quantum computers. I don't know, whatever you want to do, right? Smart contract as well. We got provided you with some audited smart contracts, of course, here, and you can simply import them as well. So how does it now actually look like for the developers among you? So in the smart contract itself, that's really all you need to do, right? Like in your constructor, and if we got time, happy to go over some actual code as well. In the constructor, we basically just provide the address to a hybrid account that we need to deploy beforehand. That hybrid account basically is your, let's say, ID, right, to access your own backend, so that not other people can trigger your backend from their own smart contracts, right? So we provide that here. And this down here, basically, is your actual API call, right? So there's I would say 2 things or 3 things that are particularly interesting here. On one hand, that middle part here, that's the API call. That's it, right? That's your TypeScript fetch, for example, or your Axios or whatever. You make your API call here, and you directly get the response, or if it failed, the error here. That's it, right? And as every request, you need to tell it like, what do you want to call? Like what kind of function that you implemented on the backend. That's basically just an identifier, so to say, so that the backend knows, okay, let's get the price, like in that example. And here we have the parameters that we want to pass to the backend itself, right? And of course, we need to encode that. So that's basically all that happens here. We encode the parameters, we make the off-chain request in one line of code. Here, which I would strongly advise to do, is to just check, did the API call succeed? Of course, this very likely fails regardless if it didn't. And down here, if everything worked well, you basically get a bytes, let's say, data field here, which you need to decode, right? So you need to know what the backend returns. In our case, our backend returns a price, and we decode that. So how does it look on the server? Hopefully as easy as you would expect it to. So you have a simple, like that's the full code, like the server itself, right? You instantiate the SDK, backend SDK, that's TypeScript, for example, and then you add your server action. As you can see, we have get price string here, and here as well, get price string, which is the same thing and needs to be the same thing. So whenever the smart contract makes a call to this backend, we basically, or the backend knows, hey, go into that thing where we have our comment here, handle action. So we basically get into that part. And here happens the magic, like whatever you want to do, right? Basically, the first thing we usually want to do is we want to read the request parameters, right? Like when we look back here, we provided a token parameter. Like when we want to get the price, we said, okay, I will provide you a string, and that's the string, which is the token address. Or actually in our example, it's really just a ticker name BTC for Bitcoin, for example. So we get in here and we get the parsed params here. So you basically have BTC in that TypeScript object. And then you can do your stuff here. That's it, right? So you can do your API call to get the price. You can do your AI calls, whatever. And then same here, we need to encode the response again so that the smart contract can actually understand it, right? So we generate the response and decode it so that the smart contract here in that line then can actually decode the bytes value into the price. And on the front end, it doesn't look much more complicated as well. You also have your HybridCompute client SDK. You provide the chain ID you want to build this on. For example, right now we are on Boba Sepolio and Boba Eve mainnet. And here account ID is just your wallet, your smart wallet, for example, right? And yeah, here, like just like in every front end, you basically build your transaction here, and then you send it here. That's basically the MetaMask API. Let's put it that way. For example, you invoke the MetaMask snap here, which you need to install. We did our best to get it into the official store by today. I guess we get into the official store by this week. But so far you would need to install MetaMask Flask, which is the preview version of MetaMask. But yeah, doesn't stop you from using HybridCompute, right? You still have all capabilities for mainnet and Sepolia. There's not much bad about it. So of course there's more documentation, there are more details on that. And yeah, would strongly advise you to check that out. Of course, as Alan pointed out, we have a community as well, which if you want like blazing fast support, then join that. And yeah, I would say let's get into a little bit more practical things. So this is the example that we just looked at, for example. So here, for example, is the BTC, the token symbol that we are providing to the smart contract here, right? Which is the token that is being passed through HybridCompute in our smart contract. And when we invoke HybridCompute here, we basically get the price through HybridCompute on chain to our dApp. Right, so this is basically how it would look like. And I would definitely say that's, I would say, the closest thing that we have to an Hello World example, because it's really, really simple. And of course, that repository is open source as well. If my internet is fast enough for whatever reason. I will just post it into the chat for a second, if that works, for everyone that is curious. And basically, we have the same things here. Like I already cloned it so that we can check it out. So if we go into the smart contract, we have here the instantiation of the hybrid account, which is part of our SDK, smart contract SDK as mentioned. And we basically, you have to deploy the hybrid account before that. So that's really just to identify that you are the person that is accessing HybridCompute, like this smart contract is authorized to do that. And here again, we have the identifier for the function and the signature itself, like what parameters does it expect, and the actual parameter. Like that token, that's the BTC that we just have seen on the screenshot. And here is the off-chain call. And here we get the response. And here we decode the price. So we actually see, hey, that's the price of Bitcoin. And then in this case, we just save it into a struct, I think, or mapping and a struct on our smart contract. On the backend side, that's also what you have seen on the slides. Right? We have the add server action, you have the get price, and you have the action here, like basically what happens. And the action is nothing else than our function, right? You get this typed off-chain parameter. And here we parse the request. And then we basically can decode the token symbol. And with every day, these things get easier and easier, right? But as you can see, already here, you can do your own stuff, right? I'm calling the coin ranking API here already, Web2 based. Like if you're a developer, that should be really easy for you. And here you get your price response. And then we basically just encode it. Like that's the encoding part. And we generate the response. Right? And this is what is being returned to the smart contract right here in the next line. That's what we get here. And on the front side, it doesn't look any different, right? Here we have the SDK, as you have seen before. Here we have the build invoke transaction. And here we say, hey, let's call the fetch price function with a parameter string, which is here, fetch price parameter string. We build the transaction, we say, okay, like what's the smart contract? Like this is a white application, that's why it looks like that when accessing like an env var. And here we basically pass the BTC or the ETH ticker string, right? And value just means like, okay, we don't send funds to it, it's not payable. And then here we actually really just say, hey, let's invoke it. Let's actually execute this thing. Right? And that's really the full magic of HybridCompute. Like I would dare to say, of course, it always can be simpler, but like it's already, I would say, super, super simple. Right? So that's kind of the full complexity of that. And now I would suggest, because I always prefer this to be a little bit more interactive. I'm not sure like how much time we have left or if you're done. If you got any questions, let's go over them. Hope you liked it and hope it was not too much or so.
Amazing. Thank you so much, Kevin. That was really, really informative and super interesting. I hope you guys enjoyed it as well. And yeah, if anyone has any questions, please do pop them in the chat now. I think in the questions box, Kevin, 2 people asked some questions. I think Helen asks, she's new to this. Can you suggest a project that she could try to learn through doing?
Where's the question? Oh, sorry. Could you repeat?
Do you see the chat at the bottom and then there's a questions? It's in there.
Like from Helen, I
Yeah.
don't. I just see the GMs, and then when I send my own link, I
Oh.
don't think. I just see. Can we get the slides, please? That's the only question. And how is the quality decided? This is
Okay.
great. Can I play? These 3 questions.
Sure. Yeah. Go for it. Go for it. Do you
Sure.
want to?
Sure. Yeah. Well, I mean, I think the can I play is, I guess, related to the PreziBot example, if I'm not mistaken. Yes, you can. It's live here. It's hosted on a free version, which means on the first load when nobody has been using it, it takes a minute or so to load. But once it's there, like now, you actually can use this, right? You have to install MetaMask Flask. In this browser, I don't. And then you basically can play. That's PreziBot, but that's part of another presentation. I think that's yeah, what Boyan is talking about. And what was the next? How's the quality decided? I think that's like quality decided in terms of what, KJ? Is it in terms of the response quality from HybridCompute, or is it more specific to PreziBot or CodeCaster and these kind of things, like how these things return the proper response? How is HybridCompute different than Chainlink? Okay. Yeah, Chainlink is an oracle. HybridCompute is not. HybridCompute is, I would say, a pipe. That's how we defined it a while ago. So which means HybridCompute and Chainlink or oracles in general are different in a lot of ways, right? Chainlink is, their focus point is in providing distributed data to you, right? And this is the reason why you need to wait for the information to arrive in your smart contract. That's why you have callback, for example. When it comes to HybridCompute, you basically follow a pull model, right? Just as Alan said, Chainlink has a push model for price feeds, for example. HybridCompute has a pull mechanism. You basically get the data on demand, instantaneous, right? You get it immediately, which of course has different implications as well. Quality of the PreziBot policy making. I mean, that's really just implementation feature, right? Like when you build PreziBot yourself, for example, you could do whatever you want, right? So that's really just an implementation detail. I would need to check like how it's being done right now, but I can share the open source repo with you. So it's really basically, if you look in the backend, but that's not, let's say, has nothing to do with HybridCompute itself, right? Why am I now here again? Follow my PreziBot. Okay, here. Yeah, that's basically the logic, right? Like if you're in PreziBot, you start a new game and you basically can see what it does there, right? So whatever you want to do, like how is the policy making, it basically depends on how you want to implement it as application developer. It has nothing to do with HybridCompute. What is the architecture? I suppose the client calls the smart contract. How does the smart contract know the right backend to call? That's a great question, Martin. Basically, let's go back, or let's look at that first. If you go to this slide, you basically have your smart wallet, which through the smart contract, also you basically have to use account abstraction, as mentioned before. So you send a user operation to the bundler, right? That's basically what we do here. Where is it? That's basically what we do here. We build a user operation that we define with sending to the smart contract, yes. But it's being sent to the bundler, right? And the bundler does his bundler things, like in account abstraction. And what the bundler does when you estimate the call, which is being handled by the client SDK, it actually makes the API call to the smart contract. And how does that work, to answer your question? Like with providing that address here, you basically define this hybrid account is coupled to this backend, right? Those two are interwoven, intertwined, whatever the right word is. So that's kind of how they relate to each other, right? That's how the smart contract knows which or the bundler knows which backend to call, right? So that's basically through defining which hybrid account this is. And this coupling right now needs to be done by us, right? We are working on making that, let's say, permissionless, or at least automating that. But right now, you basically DM us on Telegram or wherever, and we whitelist your backend. Let's put it that way, right? So it's that's the flow right now. So we need to configure the bundler to link. I mean, we do that. You just let us know, hey, Kevin, that's my backend, that's my hybrid account, and then we will, like, of course, free of charge, right away, we'll whitelist you, and that's it. And so that's kind of how it works. And in future, we plan to create dashboards and these kind of things for that. At least that's what I think we want to do. Of course, I can't promise that at this point. It solely depends on how many people use this in the next few months. Awesome. Cool stuff.
Great. I think the only other question was about sharing the slides. If you potentially have a link to them that you wouldn't mind sharing in the chat now, and also I can circulate that to everyone in the YouTube description for the recordings, so that you guys have access to it outside of this live session, because I had a lot of really useful information on it.
Like Alan, maybe if you want to give me a final confirmation if it's okay to share the slides. I think it's public, but cool. Thank you.
Thank you. Exciting. Thank you so much. Are there any other questions from anyone? I know that was super informative. So if all your questions have been answered throughout the workshop, that's also so fair. Yes. Oh, perfect. And Alan's slides as well. Yes, that's really useful. We can circulate those after this as well. Great. Well, if anyone has any final last-minute questions, please do pop them in the chat. But if not, that was the end of our first workshop today. Thank you very much, Alan, and thank you very much, Kevin. It was super informative, super interesting, and a really good start to this Educate series. I hope everyone who was watching enjoyed it, and we will of course, record this and edit it and upload it onto our YouTube by tomorrow, so you guys will all have access to it. We'll circulate the slides, and I hope everyone has a great rest of their day, and we'll see you all on Thursday for the next workshop. Thank you guys very much, and yeah, we'll see you on Thursday. Great.
Thanks,
Bye.
everyone.